So let's start off the pre-assessment before we get into maximizing revenue with quadratics. So can you guys get out a whiteboard and try and multiply that out completely for me, please? 2, 1. Okay, I'm seeing this. This is an extremely common mistake. N squared plus 9. Okay. That's not n squared plus 9. No, not 2n squared plus 9. If I were to multiply, are you guys going to let me talk, or you just want to talk? Perfect. Okay. So this is actually n plus 3 times n plus 3 times 2n minus 3, right? N times n is n squared. 3 times 3 is 9, which you guys have good. The only time there's not a middle term is when this is positive and this is negative, like the difference of two squares, right? Because this is a perfect square trinomial, it's actually 3n and another 3n that makes 6n. That was our first mistake. So this, right here, is now this. I'm going to put parentheses around it because it's still being multiplied by 2n minus 3. Now, you could FOIL this. It's a little complicated. It's a lot, right? Because you're going to have to multiply the first term by the first term, the first term by the first, then the first times the second. Then you're going to multiply the middle times the first and the middle times the second. Then you're going to multiply the third times the first and the third times the second. I'd rather just use an area model. It's a lot easier. Draw a box. Make it, give it some structure. So I could say n squared plus 6n plus 9, and I'm going to multiply that by 2n minus 3, right? Isn't that easier? It's just like a multiplication table. When you're multiplying, just turn it into a multiplication table. It organizes your work a little bit better. So now I have, why don't you guys try that? Now that I've got that, erase that, and why don't you guys try that? Recording. Okay, so 2n times n squared is 2n cubed. 2n times 6n is 12n squared. 2n times 9 is 18n. Negative 3 times n squared is negative 3n squared. Negative 3 times 6n is negative 18n. And negative 3 times 9 is negative 27. I'm going to go find those like terms now. Alright, so we're going to start with, this is my only cube. So it's 2n cubed. What's my next color? Purple. Here's an n squared, and here's an n squared. So 12n squared minus 3n squared is 9n squared. Positive 9n squared. I have, it looks like, let's do it black. Negative 18n, positive 18n. Those are zero pairs. They cancel each other out. And then we're finally just left with negative 27. Easy? Okay. Good. Yeah. So that's simplified. That's our answer. Yes. No, that's structure. Yeah. Well, it depends on if it's set up in descending order and set up in descending order, then it's going to fall. It's going to multiply out in descending order. Okay. All right, guys. Flashback. What are the zeros? Work together as a group. Right here. This is a quadratic equation. How do I know it's quadratic? Because it's got x times x, which is x squared, right? So this is quadratic. Find the zeros. How would I find the zeros? Let me give you an idea. Let me give you a little clue. 0 equals 5 minus x, 2x minus 22. Find the zeros. 5, 4, 3, 2, 1. Back up. Check this out. If I gave you this, y equals x minus 2, x plus 3. What are my zeros? You guys got that. X equals 2 and x equals negative 3. So what are my zeros here? Okay, let's set them up to 0. I'm glad you guys have more confidence now. So 5 minus x equals 0. Negative x equals negative 5. If I subtract 5 from both sides. Now multiply each side by negative 1. X equals 5. Right? This one, I would move the 22 over to be positive, and if I divide both sides, x is going to be 11. All right, so my zeros on this one are x equals 5, x equals 11. What's my axis of symmetry? Somewhere in between. How are you going to find that, Gino? Count. Draw yourself a picture and count. It's 8. If you add them together and divide by 2. Or we could just draw ourselves a number line, right? If this is 5, and this is 11, 6, 7, 8, 10, 9, 8. Yep, it is, right in between. Add them together, divide by 2. So my axis of symmetry is going to be x equals 8. My zeros are x equals 5 and x equals 11. How do I find the vertex? Plug in the x. Substitute x back in. So let's substitute x back in and see what happens. So if I put x in here as 8, I would have 5 minus 8. Minus 8 and 2 times 8 minus 22. So what's that equal? 5 minus 8 is negative 3. And 2 times 8 is 16 minus 22 is negative 6. So it's going to be positive 18. So my vertex is that if I'm over at 8, I'm going to have to go up at 18. Okay. So we should be able, even though this is written in a different way than we're used to, right? You guys haven't seen it like this before. It still gives us the same information that we've been doing over and over again. Right, Bryce? Yeah. Okay. Just making sure. Okay, now you just sit up. All righty. I don't think I'm going to spend the time to do the other one. I think I'd rather, no, I want to get going on this task. Okay. Have plenty. Alrighty. Okay, we're going to start this task together, and I'm going to see if I can get you guys to go where I want you to. Spoiler alert, we're probably going to make what type of function? Probably going to be quadratic, right? Quadratic will be squared. Cubic is cubed. Okay, so this is where I want you to start. You guys all have this task in front of you. I want you to begin by just looking at, change the outside of this. I just want you to look at this right here. Can you guys just fill out this column right here? Actually, let's fill out this column and the price per bag. That's it. Based on the information that you have. That means you got to read. You got to read the scenario, and I want you to fill out those two columns for me, please. Each box is a different, yes. Is it talking about months? Yes. I'm going to go ahead and give you guys a second to do that. Work together. 3, 2, 1. Okay, so it says that the Golf Shack sells 30 golf bags per month when it charges $200 for each bag. So 30 bags when it charges $200. It says the Shack decreases the price by 20, it sells 5 more. So this month, they decided they're going to drop their price. By how much? By $20. So this month, they're going to drop it down to $180. So how many golf bags are they going to sell in this month alone? 35. Not the total they've sold, just this month. We're just looking at this month when they charge $180 a golf. They actually make $35. I mean, they sell 35 of them. Okay? So then they decide, you know what? We're selling more by dropping the price. So they decide they're going to drop the price again. So they're going to drop it down to $160. How much are they going to sell this month? 40. You tell me, you think they're making money or not? But they're dropping the price. To a certain point, right? Okay. All right. So, I want you guys, before we do anything with this algebraic, I want you guys to try and figure out the revenue. Where is it where they're going to make the most money? They've got to figure that out, right? Because they can't just keep dropping the price. So they're going to drop the price again. So how much the next month are they going to decide to sell for? 140. And how many bags are they going to sell? 45. And then 120. And they're going to sell 50 bags. So work together as a group and figure out the revenue. What does revenue mean? What do I mean by revenue? How much they're gonna? How am I going to figure out this first month how much they're going to get? It doesn't. It doesn't matter whether it's gross or net. We're just talking about how much they're making from the bags. Okay. So how do I figure out how much they're making from bags this month? Multiply 30 bags times 200 a pop is how much? $6,000. You do the math for the rest of it. 3 times 2 is 6. Add 3 zeros. 2, 1. Okay, so we've decided that the revenue, we've figured out the revenue. We've figured out that right here in the middle is where they're going to make the most revenue. Now let's go back and try and make sense of this algebraically. All right, so really we can't do any math here, right? But let's talk about what happened here. We had $30 bags, right? And we added, what did we add? We added 5 bags one time. Or we added 5 bags. Let's do that. And then here we had 30 and we added 5 and 5 again. Or 5 2 times. And then we had 30. Where do you think I'm going with this? 5. How many times? 3 times. Because I increased it 1, 2, 3 times. There was 3 increases, right? So what's this one going to be? 30 plus 5 times 4 increases. So let's write an algebraic expression. I don't know how many times it's increased, but I know it was 30 plus what? 5x. Okay, do you guys think you can try and do this one? You need to start right here. You can do it. I love it. I'm going to give you 1 minute. Try it. Try it together, and then we'll do it together. So the top one, you don't worry about this one, right? Because this is when something has changed. So So this is going to be, I'm not going to do it. You guys are going to do it. 2-1. Let's see how you guys did. You weren't done. Okay. So what happened? How did we get from here to here? 200 minus 20. And how many times did we do that? 1. Right? Then we did 200 minus 20. How many times? 2. Good. Be proud of yourself. Own it, Joey. And then we had 200 minus 20 3 times. And 200 minus 20 4 times. So if I want to find out an X amount of times, I would have an expression like that. How are we doing so far? Pretty good? Are we understand where all these numbers are coming from? Fantastic. So, hold on. So, when I tried to find total revenue, didn't I multiply straight across? Right? Didn't I multiply 30 times 200 to get 6,000? So to find my formula, I need to multiply this times this to get this. Yeah. Okay, let's move on. All right. So write the equation you developed above to find x and f of x. No, hold on. So if I multiply this times this, right, I'm going to get f of x equals 30 plus 5x times 200 minus 20x. What is x? X is the bags, right? The number of bags? Number of bags. And what's f of x? Not the price, the revenue, the total revenue, right? That's how we figure out the total revenue. Wouldn't it be what? Yeah, the amount, the total amount we're going to get from the bags. Okay, using your answer from part B, which should have been this, should have been part B. What are the zeros of the equation? Can you find the zeros? These are the factors, right? What are the zeros? You should be able to figure that out. Remember this? How do we find zeros again? So find the zeros for me. Fun. Did you guys come up with the zeros? What are the zeros? Negative 6 and 10. Good. So we got negative 6 by setting that up to 0. So we got negative 30 equals 5x. So x equals negative 6. And then if I set this other one up to 0, I get negative 200 equals negative 20x, and x equals 10. All right, knowing the zeros, find the axis of symmetry and the vertex. No, axis of symmetry is not 4. It's 2. How'd you get 2, Aaron? 10 and negative 6 makes 4, and half of that is 2. So I'm going to go ahead and plot negative 6, 1, 2, 3, 4, 5, 6, and 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know you guys have been figuring out if you add the two zeros and divide by 2, you get an average, which is 2. Axis symmetry is 2. how do I find the vertex? Plug it back in. It gives you a really big number. Huh. It gives you a really big number like 6,400. That sounds familiar. That's the maximum revenue, right, Jaden? Let's go back and look at this. Let's make sense of that number 2, axis of symmetry 2. Do you guys see another 2 up here? Where is it? It was the second time we lowered the price, right? The second time we lowered the price. So our axis of symmetry is at 2 because we lowered the price once, it changes the revenue. We lower the price again, it changes the revenue, correct? But if you didn't get that connection, you could have just put 2 back into the equation, which is, let's do it here, f of x equals 30 plus 5 times 2, and we're going to multiply that by 200 minus 20 times 2. If I put all of that in, I'm going to get 6,400. Now we got to figure out how we're going to put this on our graph. Well, go by thousands? I would go by 2,500. So 2,500, 500, 7,500, 1,000. We'll go with those thousands. So 1, 2, 3, 2,000. Is that going to work? 1, 2, 3, 3, 2, 3, 4, 1, 2, 3, 5, 1, 2, 3, 6. Not quite. So go by 500. All right. So 500, 1,000, 2,000, 3, 4, 5, 6, 7. So 6,400 would be at, if this is 6, it'd be like right here. So here's my graph. Goes like that. No arrows. Why? You can't go negative revenue, right? Okay. Not in this scenario. All right, I'm ready to move on. You guys ready to move on? Give you about 15 seconds. Okay, so I like Aaron's question. He's talking about arrows. We obviously wouldn't have arrows here because that would be negative numbers, right? And then, Aaron, did you ever consider the fact that we really don't even need this side of the graph? This has no meaning to me, right? Because we dropped in price, dropped in price. I guess if you go the other way, you're increasing in price, right? Yeah. But we really are only talking about this part of the graph right here. Yeah. You know what I mean? Okay, let's move on. Let's finish our connection. All right, so now multiply or FOIL to write the equation from part B in standard form. So we're going to write it in standard form. So you guys remind me because I don't have it up here. F of x equals 30 minus 5. No, we are increasing, right? Increasing by $5. And then we were at 200 and we were our 5 bags. And then we were 200 and we were decreasing by $20. Can you guys come up with an equation in standard form? Jay, I need you to wake up. So multiply it out, FOIL it. I'm going to do 30 times 200, which is 6,000. And then 5 times negative 20 is negative 100, x squared. And then my middle 5 times 2 is 10, so this is 1000x. And this one is 3 times 2 is negative 6 with 2 zeros, negative 100x, which gives me 400x. There's your quadratic equation. What's the y-intercept? 6,000. Right? My y-intercept is when I'm at 0 on the x-axis, I'm at 6,000. That was one of the biggest problems you guys had on your test. This is not the y-intercept. That is just a number. Right? This is the y-intercept. When x is 0, y is 6,000. Does that match our graph consistently? When x is 0, y is 6,000? Absolutely. It's right there. Right? It matches. Jay, I need you to sit up. All the way up. Thank you. No, y does not equal. Y equals 6,000 is a line like this. That's y equals 6,000. Yes. If you went up 12, up the graph by 12, I went up, I was counting by 500. 500, 1,000, 500, 1,000, 500, 1,000. Yes, sir. Oh, come on. Okay, okay, I'll listen. Okay. No, that's not right. You've got to be able to understand. Do you guys hear what Kane said? He said, he asked if you aren't very skilled at drawing parabolas, and you draw your parabola, and yours looks like it's at 6,300 crossing the y-axis, you would know that your graph is a little incorrect because when you multiplied it out, you actually got 6,000. So you should know that your y-intercept is 6,000. Make sense? So you've got that other evidence. Okay? All right, so now write the equations from part F in transformational form. How do I go from this right here and put it in transformational form? What you guys did last night, supposedly. Right? All right, f of x equals negative 100x squared. Everybody pencils down, just watch me do this. Plus 400 x plus 6,000. Am I correct? I can't. Well, first of all, what I'm going to do is I need to complete the square. Correct? What do I normally do when I complete the square? What do I move? I'm going to move the 6,000. So I'm going to say y minus 6,000 equals negative 100x squared plus 400x. Now what else is problematic with this? What does it have that I don't want? Negative 100. How can I get rid of that coefficient of x squared? How do I take it out? I should have everybody looking up here because this is probably the hardest part of the lesson. I'm going to divide, right, Nate? How much am I going to divide by? Negative 100. So I'm going to go ahead and divide everybody by negative 100. Can I do that? As long as I do it to everybody, I have to divide everybody by negative 100. Correct? Because that makes everything equal, right? So when I do that, I get y, or we'll say negative y over 100. That looks gross. Forget about it. We're not even going to do anything with it right now, okay? Then 6,000 over negative 100, the negatives cancel, my zeros cancel, and I'm left with 60. Everybody okay with that? These cancel, the hundreds, and I just have x squared. The hundreds cancel, and I have negative 4x. Is this easy to complete the square now? Yes. What am I going to add to both sides to complete the square? Negative 4. Hold on. Not minus. I'm going to take negative and divide by 2 and square it. So this is going to be negative 2 squared. Negative 2 squared is 4, so I'm adding 4 to this side too. Are we good so far? Okay. So now I have negative y over 100 plus 64 equals x minus 2 squared. Correct? Okay. Now, if I want to, let's see here. I don't want a coefficient with this, right? Correct? What can I do to both of these to avoid this having a negative 100? Multiply it, right? Correct? All right. So if I put a negative 100 out here, and I multiply back, right? I pulled out 100, and I pulled a negative. Don't I have y now? Well, what's this number going to be then? It's going to be negative 6,400. And this is why, because when I take and I multiply, actually, I'm pulling out negative. I'm pulling out this, right? I'm pulling out negative 100 out from the outside of it. Does that make sense? Okay. We have it over here. Negative 1 over 100. This is what we have. Plus 64. I want to factor out negative 100. So I only have a y. So when I do that, I must have to make this, because if I were to redistribute this, I would get this. And redistribute this, I would get this. Yes. Hold on. Can everybody just give, you got it. But there's people that are looking at this going, just don't talk right now. I just want to look at it. Okay? You just leave it like this. Okay? It was already a fraction. Right here. There's a fraction right here. But when we put it in transformational form, do we ever see we usually see an LLR. The LLR is pulled outside, right? Joey, I need you to sit up, please. Okay, let's make sense of it for just 1 minute. This is the vertex, right? This is the axis of symmetry right here. We go over 2, and we go up 6,400.
But shouldn't the 4p just be a negative 100? Why over 1?
Well, isn't this what, this right here is right here. Oops. This right here is the same thing as this, correct? Yes.
Why so? Because I thought you wanted to multiply the 100.
Isn't this exactly the same as that? All I did was just move the y over. It's just like this. If you have negative x over 2, that's the same as saying negative 1/2 times x.
Yeah.
So these are the same. Right? These are both the same. This is the same as this.
But I saw that when you separate the y, that you have to times the 1 over 100 by 101. And so...
Please don't pack up.
I just want to know why it's still a fraction.
Please don't pack up.
Yes,
You're factoring out. If you had 2y, wouldn't you factor out a 2?
A 1 over 100.
You're factoring out a 1 over 100.
Okay, yeah, and I had multiplied it by the...
Okay, So this is what I want you to do. I have another task for you. Hold on. Everybody's packing up and thinking we're done. I have another task for you, and it's written in the exact same format. So if you have this copied down, you'll be fine. I'm going to give it to you right now. Why would you not copy this down? It'll also be on Schooloop. Okay. There's no reason why you guys shouldn't be able to make an honest attempt at this, correct? You're welcome. I hope you guys have a fantastic day. Thank you. I won't be here at tutoring, but there will be teachers that will be.